Brothers podcast, a Five Pillars of Mad Monolith production.
Assalamu alaikum wa rahmatullahi wa barakatuh, dear brothers, sisters, friends, and foes, and welcome to another episode of the Blood Brothers podcast with your host, Dilly Hussain. Today's episode is a continuation of the COVID-19 series, which we started 2 weeks ago, whereby we invite scientists and healthcare professionals to provide their analysis and insight into the current pandemic. Now, before we introduce today's guests, for the sake of time sensitivity, the date of filming this podcast is Wednesday, the 8th of April. By the time we release this podcast, the most updated stats will be on your screen. And unfortunately, it is expected for those numbers to increase in terms of the positive cases of coronavirus as well as the death toll. However, we hope and pray for that reality to change and there to be a steady decline. Today's esteemed guest is joining us all the way from Canada. He is the assistant professor at the Canada Research Chair, the University of Manitoba, and he's also a virologist, and that is Dr. Jason Kindrachuk. Dr. Kindrachuk, welcome to the show.
Thank you so much for having me.
No, thank you for giving us your time. Let me set the mood for today's podcast, and let me ask you a few quickfire questions.
Sure.
However, I have two requests. Request number one, that you kindly keep your responses and explanation as brief as possible, as there will be ample of time to elaborate and expand on some of these things later on in the podcast because it is relevant to today's subject matter.
Sure.
And secondly, if you can kindly keep your explanation as simplified as possible for us lay folk to understand some of these very technical scientific terms. Is that fair?
I'm a lay folk as well, so absolutely.
You're a lay folk with some big guns there, so you're not the everyday lay. Okay, what is a virus?
A virus is basically just a piece of genomic material inside of basically a ball of protein with some fat on the surface of it.
And are all viruses contagious?
No, they're not. They're not all contagious.
And can viruses be independently engineered in a laboratory?
Yes.
What is an exosome and how is it relevant to viruses?
We don't fully understand yet what the relationship is.
But what is an exosome?
So an exosome is basically just essentially it looks like a mini cell that is released from our actual cells themselves, and we don't quite understand what the function of them are yet.
Okay. And lastly, what is the most common animal used by virologists to experiment on, and why?
Probably mice. Mostly because they're cheap and they're easy to obtain.
Wow. I was expecting brief responses, but they were really brief. But I will probe you on some of those issues later on. Now, Dr. Kindrachuk, you came to my attention recently when you did a brief rebuttal on CBC News to Dr. Thomas Cowan's 10-minute lecture. Dr. Thomas Cowan's video has since gone viral, and many commentators have basically said that it is being used as one of the main sources to legitimize and normalize the kind of 5G and COVID-19 theory. Now, whilst I appreciate that radiology and electromagnetic frequency is not your area of expertise, I would like to pick your brains on some of the things that he said and just get your general thoughts on it, yeah?
Yeah, absolutely.
Now, he referred to... In that 10-minute talk, he referred to the electrification of the world, right? And he cited Rudolf Steiner. And what he did, of course, is he cited a number of historical events, and he drew correlation with certain pandemics that broke out round about the same time. So the end of World War I and the Spanish flu, the 1968 Hong Kong flu, and satellites being sent out to the Van Allen belt, the rollout of 3G and SARS, and of course, 5G and COVID-19. What's your thoughts on these correlations that he cited?
So this goes back to this whole idea of correlation does not equal causation, right? Because ultimately, what I can do is I can say, if we look at global warming and we look at, I think the easiest example is the global increase in pirates, which has been used quite often in graphs. What we can see is that basically the number of pirates has increased as global warming has increased. So does that mean that pirates are causing global warming? And ultimately, no, it doesn't, right? They both are tracking at the same time and basically increasing, with some correlative similarities, but they're completely unrelated. And I think that's when we look back at some of this data. Yes, there are things that happen to correlate with one another in terms of time frames, but there's also a lot of events that are not being discussed within there. I mean, the 1957 pandemic is strangely absent, which was Asian flu, and that killed 1 to 2 million people and was the first pandemic post 1918. And then, of course, we could talk about HIV and all of the epidemics that have occurred in between those time frames and say, how did those correlate? And if they did correlate, was there a causation between them? And I think that's where the question really lies.
From my limited research, which I've carried out over the last week or so, because I don't know about what's happening up in Canada, but in the UK, this 5G theory and COVID-19 is spreading like wildfire, right? Mm-hmm. And when I did some research, I saw that there is scientific literature that clearly states that, look, 5G telecommunication waves can have serious health implications. For example, and I'm going to just cite a few things. So, for example, sure. there was 180 scientists and doctors who in 2017 wrote a letter to the European Union, and they raised serious concerns. They asked for an independent task force to investigate the matter. Apparently, there is a petition signed by 26,000 scientists. I've not seen the list. I couldn't find the list of names, but it's doing the rounds. Mm-hmm. But there was also a piece of research by Professor Martin Paul from Washington State University in 2018, where he highlighted 8 serious health implications from 5G, like the nervous system, reproductive systems, and increase of cancerous cells. Given this kind of literature that's available in reputable journals by qualified scientists, right? And whilst there isn't a consensus, there is this material that's out there. Are you entirely surprised that this theory is gaining increasing amount of traction in light of what's available about 5G and the timing of COVID-19?
Yeah, not at all. And to be fair, listen, I would be a horrible scientist if I sat back and said, we should not investigate whatsoever because there's simply nothing going on with or potentially going on with 5G. I mean, like you said, it's not my area, but I think that ultimately we know that some concerns have been raised about if there are any physiological effects due to the type of electromagnetic waves or radiation released by 5G. And I think those things need to be investigated. But at the same time, I also hasten to say that trying to make direct correlations with something as complex as infectious disease now is pushing into an area where you're now trying to say that there's definitive causation based on people raising concerns. And I think that's where we need to say, yes, we need to be cautious, but that doesn't mean that there is some underlying motive behind all of this either.
I mean, without specifically citing any names of doctors or scientists, why has there been the likes of Dr. Thomas Cowan and others? There's not many, but there have been some that have made a direct correlation, right? What do you think has inspired this thinking?
So this is a tough question, right? I mean, listen, we've seen this within the anti-vax community for a long period of time. We do tend to see sometimes, I guess, again, I'll use correlation with people that maybe have run into being discredited, that are looking for maybe some ability to gain some traction back or gain some of their prestige back, understandably so. But I think I think if we separate all of that back out, what we have to think about is the fact that when we think about infectious disease, this is something that it has been plaguing us since the dawn of time. And we are still in an infancy of being able to actually explain, why do pandemics occur? Why do viruses spill over? Why do bacteria develop resistance? When we get into this area of not being able to give a specific reason why things happen, I think people start to look for things that will maybe give them some feeling like these things aren't just based on chance, and maybe try and have any explanation, even if it is ridiculous or doesn't make any plausible sense. Having something to be able to correlate it back to ultimately maybe makes people feel like they understand the world, and they don't just feel like things are happening purely by chance.
But wouldn't it be a fair assessment, to say the least, that we are living at a time of advanced technology we are living at a time, at least for the last 50, 60, 70 years, where technology is continuously modernizing and communication is becoming literally instantaneous. And as a result of this, we are having to use modes of communication that requires waves and frequencies and stuff like this. And so, I mean, from your knowledge, are you still maintaining the position that there isn't a direct correlation between the use of modern warfare, electronic devices, and all these kind of technological stuff, and with the spread or cause or the speeding up of diseases?
Yeah, I mean, listen, my take is still that there isn't. And I think that goes back to historically, if we look at things, obviously, like smallpox or plague, we are seeing increased frequency of outbreaks and spillover events. But I think in a lot of cases, those can be directly related back to human practices. And I think that's where we have to maybe take a step back and understand, what are we doing specifically that puts us in more direct contact than we maybe would have been 50 years ago or 100 years ago. And to be fair, I will go back to the fact that, listen, with every increase in technology and with modernization, we have always seen new theories that have come up. And this is from hundreds of years ago that try to relate back to increased spread of infectious diseases.
Right, let's now delve into the crux of today's podcast, right? And let's pick your brains as a virologist.
Sure.
I'm going to posit to you some claims, right? Claims which are increasingly gaining traction, and they're being pushed forward by celebrities with millions of followers, right? Now, one of the things that's being claimed is that viruses cannot be caught. They are not contagious. They cannot be transmitted from host to host.
Yes.
Why? What's your thoughts on this claim?
I mean, I'm a virologist, so if that's true, then I'm completely in the wrong line of work, and I've given up a lot of precious time doing what I do. So let me take this back a step. So years ago, back when 1918 flu first emerged, and we got into a time period when we could first identify viruses physically, so looking through electron microscopy or looking through the microscope. There's always been this idea of, well, are viruses real? And how do we know that they are the things that are causing the diseases that we're looking at? Well, what I would maybe posit back is that, so with 1918 flu, we knew that 1918 flu had happened, but the virus was not isolated, and it literally disappeared. And that really stayed that way until the very late 90s and early 2000s, when people were able to go and exhume bodies and really sequence the virus. And following sequencing the virus, what they were able to do was recreate that virus. So essentially, recreate it from the genomic level to create, basically in the laboratory, something that you could put under an electron microscope and looked like a virus and had, it basically would be bound by influenza-specific antibodies, which meant that we could show definitively that this was influenza. Well, what could happen is that you could then take essentially that recreated virus, and you could put it into non-human primates, which we know are a pretty good surrogate for humans in terms of showing signs of disease. And what we were able to show was that not only did those animals get sick when you put that virus in, but in fact, if you looked for that virus, either looking for more infectious virus or just looking for traces of the virus, what you saw was that over time, the virus was increasing as the animals got more sick, and the animals ultimately died and had what looked like 1918 Spanish flu from a pathology standpoint or from a tissue damage standpoint. And that's one of very many examples where we've been able to basically in a laboratory pull out all of the individual parts of a virus and essentially put them back together to recreate the infectious virus. And we've done this for Ebola. We've done this for any number of viruses to be able to figure out what are the important components of these viruses that allow them to do what they do so well.
So I asked you at the beginning of the podcast during the quickfire questions that can viruses be engineered in a laboratory? You said yes. You've just said again that to carry out experiments, this can be done. So my next claim, according to a video that nearly reached 1 million views, but has now been taken down by YouTube by a gentleman called Dr. Rashid Buttar. He posited or cited a piece of research by the University of North Carolina at Chapel Hill which was carried out around November 2015. And basically, he claimed, according to this research, which is, I believe the conclusions were published on the Nature Journal, that all variants of the novel coronavirus was tested out on animals, specifically bats, and it couldn't bind with the key human receptor. Do you know which piece of research I'm referring to?
Yeah. No, I know that. I know the researchers well, and I know that what they've accomplished with coronaviruses in the past.
Okay, so why did that gentleman whose video reached 1 million views claim that that piece of research, that those novel coronavirus tests that were carried out, they were carried out on bats, but it wasn't binding with the human receptor, which, if correct me if I'm wrong, he's basically saying that it couldn't affect human beings the way in which COVID-19 is affecting human beings.
Sure.
Am I correct? That's basically what he's saying.
So I'll give you a couple thoughts. So when we look at things like coronaviruses, what we know, first of all, that there are numbers of coronaviruses, right? So we know that there were 4 coronaviruses that were endemic in the human population, which meant essentially the majority of the human population was infected or had been infected by them up until SARS in 2002. But nobody really worried about them or thought about them at that time because they were cold-like viruses. And then SARS emerged, MERS coronavirus, and now SARS-CoV-2, which causes COVID-19. So what we know is that we're not limited to only those coronaviruses. There are coronaviruses that infect animals. They're basically a massive amount of coronaviruses that fit within that family. Nature is an unbelievable engineer and is far better at doing engineering than we are in terms of being able to create new viruses, because nature essentially allows these things to happen a lot faster. And essentially selects for viruses that can continue to create more copies of themselves. So what the researchers ultimately were able to show was that the viruses that were circulating, if you basically changed up some of the genetic code, what would happen is that you could basically show that these viruses now were able to adopt these different abilities or these different activities, which may allow them to infect human cells. Now, where that's important for us is when we think about this idea of gain-of-function experiments, and this has become a hot-button issue within research for a number of years. It's this idea of trying to understand if we basically change parts of a virus and parts of the viral genome, what is the effect that has on that virus? And we're not doing it haphazardly just to say, okay, let's just see what happens and see what we could recreate. We do this to try and better understand how viruses do what they do. Because ultimately, if you think about something like Ebola, it has 7 genes, and we have hundreds of thousands of genes. Yet Ebola kills 50% of the people that it infects. How can it do that? And with these types of experiments, what the hope has been is that if you can try to go in and figure out, well, what makes this particular protein within a virus suddenly change that virus from not having any ability to cause infection to now being able to cause infection, does that tell you, first of all, what types of mutational events we should be monitoring for in the wild when we do surveillance experiments, looking at bats to see if maybe something new is showing up? Or does it start to give us some ideas in terms of things like therapeutic targets? So rather than just being able to create a vaccine, can we create a therapeutic target that actually very specifically hones in on a piece of the virus that will completely negate or block its activity to infect us? And now there have been counter arguments that have been presented that have said we have to think very diligently about whether these types of experiments are important, because there is the potential that you could create something that is far more dangerous than what you'd ever sought out to do. But what I would say is that there are also, having worked at the NIH in the US and obviously working here and working in high containment labs, the amount of oversight on all of this work is amazing at the institutional level, let alone at the global community level. So that's where I look back on all those factors and say, okay, if you take all of that into account, does that make a more plausible case for SARS coronavirus 2 spilling over than the fact that we have millions of viruses in bats that have not been identified and we saw a spillover event occur, which we know has happened frequently in the past? and we know does happen. So I look at all of that information and say, at the end of the day, what is most plausible? Nature does this, and nature has been doing this for an unbelievable amount of time. And unfortunately, this won't be the last time it happens, but we're trying to better understand, how this actually occurs or what the driving forces are.
Now, the article in the Nature Journal has now got a disclaimer dated March 2020, and it actually states that this particular article is being used to spread conspiracy theories that the source of COVID-19 was not an animal, but it was. Yeah.
Yes.
So when you read or understood that piece of research that was carried out in November 2015 by the University of North Carolina, do you not see any contradiction between what was concluded in that piece of research and what you said on CBC, in that you're so confident in the way COVID-19 was sequenced that the data is simply too strong? Do you not see a contradiction between the two?
Well, I don't necessarily see a contradiction, right? I think that when you look back at genome sequencing, so between, let's say this has been 5 years essentially, or just over 4 years since these two events. So what we know is that there's been an unbelievable advancement yet again in our ability to do sequencing. And so I'll harken back to my experiences in West Africa on the ground during the Ebola epidemic, to now what's being done in the field for doing sequencing and diagnostics. It's like night and day.
If I may interject, what is sequencing? Tell what is
sequencing?
What is the process of sequencing?
Sure. By sequencing, what we mean is basically the ability to go in and look specifically at all of the letters that make up the genetic code. So It's kind of like being able to go in and identify essentially like the Word documents that spell out what makes that organism or what makes that virus what it is, right at the kind of the absolute facets of its molecular level.
How do you get the direct source of a virus? To test it out in a lab, how do you get that?
Yeah, so that's a fantastic point, right? So often what will happen is that, we know now that obviously humans are infected. So we know that, people in late December, this atypical pneumonia cluster showed up in Wuhan.
Yeah.
What people were able to do is you can take a biological sample. So you can basically take, swabs from somebody's respiratory tract, or their sputum, or basically put fluid into their lungs and pull it out, and basically look to see what is in there.
Okay.
And what you'll ultimately be able to do is you can basically, so you get essentially all of these different Word documents. So it's kind of like an encyclopedia that you rip all the pages out and you throw it on the floor.
Yeah.
And now basically what you're saying is, okay, tell me what is in, say, completely in there, but is there anything that matches the letter A? And what we can do is basically we can use over prior knowledge of basically sequences from different viruses that have been made or humans or any other organism. And we can essentially look to see whether or not those things are similar or dissimilar to one another. And what you ultimately end up with is the ability to basically see, based on similarity between the genetic codes, if something is the same or different. And what you're able to do, and what they were able to do in Wuhan very quickly, within, 7 or 8 days, was be able to say that sequence of that they were able to get out of these samples correlated with coronaviruses. And in fact, it was similar to SARS coronavirus, but not the same. So what it basically said was, this is something new, and based on the genome sequence and how the genome sequence was laid out, what you can actually look at is there any sort of information that suggests that this was engineered? And what we've been able to figure out, and people far smarter than me in bioinformatics, you can actually look to see the pattern at which different, what we call bases or different letters are used to basically construct that genetic code. And ultimately what you can do is you can say, okay, well, based on how specific those letters were, there's, like 99.999% probability that this was natural, and 0.0000001% that this could ever possibly have been engineered, because we're simply not smart enough to do it in the same way that nature does it.
Is it necessary sometimes to create a stronger type of a virus in a laboratory to basically prepare for what may come in the future?
So this is a great question, right? And this goes back to, again, this whole argument about 1918 flu.
Yeah.
1918 flu had essentially disappeared. So did we need to essentially resurrect it to better understand it? And now, full disclosure, I've worked on smallpox in the past. I've sat on advisory committees for smallpox. I have been a proponent of not destroying the virus. And the reason being is we can't necessarily predict what we're going to see in the future. So if we assume that we will never see another influenza virus like 1918, or we will never see another pox virus like smallpox, I think that that's somewhat foolish because nature is unpredictable, and in particular, viruses are unpredictable. So I don't like the idea of getting rid of things, in particular when they've decimated the human population. I think we need to understand what made these viruses what they were, and why do they stand out as compared to others. Now, so there's that argument that you can, is it smart to be able to resurrect a virus or recreate something that had a massive effect on the human population? So you can make that argument that yes, we need to better understand it, because if we need to create therapeutics or identify vaccines, that's how we'll do it. Which, if in the case of COVID-19, we know there's no vaccine and no therapeutics, so now we're scrambling to try to identify something. There's also the other side where you can say, okay, but if all these genome sequences are available, is there a concern that somebody could simply recreate this in the lab and release it? And I think that's where we get into the gray area where people far smarter than me basically have these conversations over and over again of how could this actually happen and could it occur? And I think people are still firmly in the camp that the likelihood is very minimal. But it is something that is consistently debated and will be continually debated for ages.
So you're from the school of thought that basically posits that, look, we can't kill off a virus. We need to keep it because we need to carry on testing on it because for therapeutics, for vaccines, etc. Right? Is that basically what you're saying?
Yeah, I mean, I'm of the mindset that we need to be cautious in our desire to say that we've defeated something. Because ultimately, if we've learned anything from viruses, it's the fact that they have been around for a lot longer than us, and they are much better at adapting to changes than we are. So I always like to to kind of have something in my back pocket just in case.
So how is a virus which is not killed off? How is a virus which is kept? How is it? Is it kept in a lab? Or is it kept in a tube? Tell us as lay folk, how is this kept?
Yeah, so the first thing I'll say is that, I mean, listen, everything is kept obviously under certain conditions. So predominantly they're frozen. But what I will say is that the amount of security and oversight is unbelievable. So I could say as somebody that is Canadian that worked in the U.S. And worked on these types of viruses, the amount of scrutiny in terms of background checks, but also psychological assessments on an annual basis were amazing. And the amount of oversight that there was in terms of not only, say cameras and specific people that were allowed to basically be able to get virus or know where the viruses were, but also in terms of being able to ensure that you had people that were always working around you. So people weren't being let in the lab alone. All of that oversight, creates a system where there's an immense amount of trust, but there's also a knowledge that there's also an immense amount of oversight monitoring your every move.
I don't mean to cause any offense about what I'm about to ask you now, yeah?
No.
You would say that because you'd be out of a job if you didn't, right?
Well, not necessarily. So for me, I'm now in an academic laboratory, right? And so we don't. I have security clearance to be able to work in high containment labs, and still do. But my laboratory actually functions fairly independently, so that we essentially are not limited by that. Now, all of that being said, the things that my laboratory focuses on also are essentially things like building capacity and expertise at the local level in low and middle income regions. So we do a lot of work in Africa, which is why I was there during the Ebola epidemic and why I still spend quite a bit of time across West and Central Africa. So I think that what I guess I would argue back is that I don't have to say that because my laboratory functions and would function independently of having those expertise. Now, we need those expertise to be able to help guide us. So if we look at things like Ebola, the vaccine that has been deployed in the DRC, that vaccine would have never been created without the ability to actually go in and work on these laboratories or work on this virus in a controlled environment. And now we know that vaccine has actually been, amazingly beneficial, at least in the Democratic Republic of Congo, to be able to curb transmission of that virus. So I think that these are kind of important factors to look at, that we're not just kind of going in and playing around. We're actually really trying to create things that will help with the betterment of society, and in particular for the most vulnerable.
Okay, I'm going to play, I don't like doing this, but I'm going to play devil's advocate here,
Sure.
right? Who are you answerable to? The lab that you're currently working for, yeah? Who are you answerable to, and who's keeping them in check? Who's accounting them to make sure that your employers, your laboratory, and the guys that you're working for aren't in some kind of agreement with major pharmaceutical companies who are going to be involved in vaccines? So therefore, you all work hand in glove. Who keeps your employees in check? Who are you answerable to?
So this is a fantastic question, right? So there are two different ways of looking at it. So from the government side, when I worked as a federal employee, we had to disclose any financial agreements that we were in. And we were also limited at being able to perform any work outside of what was mandated. Now, as an academic, I have my biosafety officer, my biosafety office at the university. I have University Central, which is basically our leadership at the university. I have our federal government health and safety office and our provincial health and safety office. And then on top of that, I have any granting agencies that are providing money either as government bodies or independent organizations to also provide information. And in all cases, what will happen is that we have to file paperwork to be able to perform the work we do. And in particular with grants, ultimately, when we think about academic labs, my livelihood is based off of the productivity of my lab. So are we publishing information, and is it deemed as being scientifically worthy? When I publish that information, I have to disclose my funding sources. And if I don't disclose my funding sources, ultimately, not only do the funders get angry, but they're not going to refund me because I haven't shown any productivity based on the money that they gave me. But in all of those forms and in those papers, what we have to provide is information on what organisms we worked with and what our biosafety proposals were and who approved them and where the work was done. And what I can tell you as a reviewer and editor, both of which are voluntary for different scientific journals across the world, we look for that information. So if somebody talks about they did an experiment with Ebola, the first thing I'm going to look for is where did they do it, who basically gave them biosafety approval, and what experiments were done. And that's how basically the scientific community has worked with this. So again, it's this idea of having a hierarchy of oversight and redundancy.
Okay. In your experience in this field, have you ever come across, without mentioning any names to avoid you getting into trouble or any kind of legal cases against you, have you ever experienced a case of conflict of interest, whereby between funders and scientists, as well as pharmaceutical organizations or the governments, have you ever sensed or observed, without going into details, conflict of interest? Because one of the claims by those who either come from the anti-vaccination community or they propagate certain theories is that, look, there are well-meaning, sincere scientists and virologists like Dr. Kindrachuk. However, it's the people and that above him where there seems to be, or there is, a conflict of interest, because they need to be working together to be making the millions and trillions of dollars. Not yourself, of course, but have you ever observed a conflict of interest?
Yeah, no, listen, in the work that I've done, I think because of the amount of oversight that there's been, in particular for, what we call, or what the U.S. refers to as select agents. So with, high consequence pathogens, there is so much oversight and regulation that I haven't seen that. I've worked in laboratories where I've I've had principal investigators who have had numerous spin-off companies and who have patented findings that they've had in their laboratory. But I still have not seen conflicts of interest where that swayed ultimately the data that was being produced in the laboratory, or the imperative to provide basically good quality information back to the public.
Going back to that piece of research carried out by the University of North Carolina in Chapel Hill, what would you say to those who have watched this video by Dr. Rashad Buttar, and basically where he claimed that, look, COVID-19 was engineered independently and a stronger strand of coronavirus was created for sinister reasons? That's what he was clearly alluding to. What would you say to those who have bought into that but are willing to hear an alternative argument? What would you say to those who have taken that perspective from that piece of research?
Yeah, so I've kind of thought about this for a while now, right? Because there's obviously been any number of stories since late December and early January about what the origins of this virus were. I guess I would stand back and say, okay, so why did that happen now, yet hasn't happened before? Okay. What is the information that we have that would suggest that this situation is any different from spillover events of other viruses or other coronaviruses that we've seen? And how can we explain, with all the redundancy built into laboratories, not only in terms of the type of testing that's done, but also in terms of being able to either get samples out of labs or disposing of samples? Outside of all of that, how physically can we put together a postulate that would suggest that this was not basically just a natural event? And that to me I have not seen a cohesive argument that has ever been produced for any number of viruses when we've seen these arguments raised that suggests anything outside of this is what happens and has been happening for hundreds and thousands of years.
Okay. Again, going back to the quickfire questions, which we opened this podcast with, I asked you whether all viruses are contagious. You said no.
Yeah.
Which viruses aren't contagious?
Well, that's the thing, right? Is that so when we look at, so if you go into, say, some of the surveillance work that's done. So when I talk about surveillance, what I'm talking about are people that actually go out into the field. So whether it's in Africa, in China, here in North America, through Europe, and they will essentially go and essentially look at animals or plants to try and get an idea of what types of viruses or what types of pathogens, including bacteria, have we maybe not identified, but could potentially be a problem for us. So what people will do is that they'll go back and they'll take samples from bats. So people have been going into West and Central Africa for decades, and essentially trapping bats and taking samples from those bats to look for viruses. And what they've often...
Sorry to interrupt. Why bats? Why bats? Why do we keep seeing bats being constantly... Why is the poor Batman always being used to test viruses?
Listen, I'll put the disclaimer out that, listen, I love bats. I think that bats are amazing. The unfortunate side is that bats, as cute and wonderful of animals as they are, they are very much like the perfect organism to be able to spread disease.
Why?
And the reason... Well, the perfect question. So we're getting a better idea now, but what we think it is that there is some ability for the bat immune system to not essentially overreact when a bat is infected. So a bat basically comes into contact with another bat that has a virus. That virus transmits to the new bat. Rather than that bat getting sick and showing signs of disease, what will sometimes happen is that virus will infect the bat and will basically start producing copies of itself. But it does that at essentially such a slow rate or at a low enough rate that we don't see a massive immune response in the bat. So kind of like when we get sick, if you get influenza, if the virus is replicating, you get a fever, you basically get chills, you get sick, and you're not doing a lot. Bats, with any number of different viruses, they don't get that response. And we think it is because there's this unique ability or unique difference in the bat immune system as compared to ours or other animals that allows that virus just to kind of basically produce copies of itself just under the surface without getting above that point where the bad immune system would attack it and get rid of it. So there's that. Bats are, they have this ability to basically change their temperature based on the environment that they're surrounded by. And we think that has some relation to how the virus basically creates copies of itself. So they have large migratory ranges. So they're a perfect organism in that sense.
So in labs, is there equal number of bats as there is mice?
That's a good question. So that becomes more of a difficulty in being able to actually care for bats in a laboratory. So there are laboratories that have bats. It's a pretty unbelievable undertaking because you have to have very specific temperatures and caging to be able to essentially provide health and welfare to bats. Whereas mice, they're much more adaptable, right?
Okay.
So that's the reason for the difference.
I mean, have you personally seen COVID-19 under a microscope?
No, and that's the reason being is that we don't have an electron microscope in my laboratory. So I've seen obviously the publications that have come out with it and different researchers that I know in the field that have published on COVID-19. But that work is also restricted to specific laboratories because of the concern about transmission.
Are those publications accessible to the public?
Yes. Yeah.
Can you cite some, please, for our viewers and listeners?
We would have to go back and find the specific papers. I can't tell you. So out of the numerous, I would say hundreds of papers that have come out since January, my ability to tell you which specific papers had an image of the virus is going to be limited. But what I'll say is that the majority of major scientific journals that have been providing clinical information and virological information about COVID-19 have made all of their publications completely open to the public.
And how does it look?
It looks like a coronavirus. So it basically is. It looks like essentially a circle under the electron microscope. Yeah. So it basically has essentially that kind of. How do I explain it? If you took a hollow ball and you cut it in half, essentially you would see kind of like the outer portion or surface of the ball, and the inside. What you can tend to see is basically signs of where the genome is. So it's maybe less spectacular for me because I've been working with these things for so long. But it's kind of like, it looks kind of like MERS and SARS.
Okay. Bringing the podcast to a close, you said that you maintain that you are from the position or mindset that viruses shouldn't be killed off or exterminated entirely, that they do need to be kept and maintained for future testing because of the many challenges that we may face as a human race with viruses in general. So then I would then posit to you then, if that's the case, even with all the oversights and the regulations and the checks and balances in place, can viruses like COVID-19 be weaponized?
So this is a great question, right? And it goes back to when we look at some of the, biological weapons programs that were present in particular in the 50s and 60s, then obviously in the 70s, those started to go into moratorium. There was a ton of work that went into weaponizing. So Dr. Jens Kuhn, who I worked with in the US and know quite well, Jens has written some unbelievable books, particularly on biowarfare, including his visiting Vector in Russia, which is basically their equivalent of the CDC, the US CDC in Atlanta. Okay. What we know right now is that the weaponization programs ultimately didn't lead to weapons that were released. And I think that's an important fact when we look back at these things. So weaponization was, I think, investigated for a while. But I think the problem that ultimately came up was the fact that, the ability to basically create a virus in the lab and then figure out how to basically take that virus and transmit it in such a way or provide it in such a way to people where they would become infected that really isn't something that's easy to do.
If I may interject.
Yeah.
Right. You said that may not be easy to do. Let's play this out then, yeah?
Sure.
It is claimed that if someone has COVID-19, that you will roughly spread it to 2.5, 3 people if you come into contact, right? If you don't have social distancing, you don't isolate yourself, We are currently seeing the number of statistics of the death toll of those who are tested positive. So in the space of 4 months, it has spread.
Yeah. Yeah.
So why then are you claiming that it's not an easy thing to spread? If I'm going by the argument, that yes, COVID-19 has been used by whichever government, state, or sinister institution, it has spread. So why can it not spread then? Why are you saying it's...
So what I guess I would posit back is, what do we know about transmission of SARS-CoV-2, which causes COVID-19? We know that it's spread by respiratory droplets, right? So if somebody coughs or sneezes, or even we think laughs, or potentially spits when they talk, that virus can be spread because it comes out of the respiratory tract. Well, when we think about when we're growing up, say virus, or we're trying to generate more copies of virus in a laboratory, we're not doing that in somebody's respiratory tract. We're doing that in basically, kind of a soup of minerals and amino acids, and basically cells that just sit on the bottom of a flask. Okay. So the factors that are likely required, or that are required for that virus to basically be spread are not the same as what we see in the respiratory tract. And that's why when we think about things like influenza, so if you go back and you look at the sheer amount of information that's ever been presented on influenza, and the thousands of labs around the world that work with influenza at any number of different biosafety levels, what we don't see are massive amounts of laboratory-acquired infections, which means we don't see a lot of people that are getting, or really any people that are getting infected by their experiment. And the reason being is that it's difficult. So I could have influenza and I can cough on somebody and spread that virus unbelievably easily. But when I'm working on that virus in the laboratory, time and science has basically shown us it is unbelievably difficult for that virus to jump out of basically the Petri dish or the tissue culture flask and infect somebody. And that's where I think we have to understand the difference between just having the virus and actually being able to infect something with the virus.
You were saying something before I interjected, something about the conclusions drawn from bio warfare. You were saying something.
Yeah.
Sorry.
Yeah. So what I was going to go back with the whole bio warfare thing is that ultimately I think what people identified was that bio warfare is inherently complicated, and mostly because nature has been essentially doing this for a long period of time and doing it much better than we ever could in terms of engineering. Now, when we look at things like smallpox, so we know smallpox was eradicated at the end of the 70s, and at basically 1980 was announced as it was eradicated and was sequestered to Vector in Russia and CDC in Atlanta. Now, from that time period onwards, we've never seen another smallpox infection. So when people ask me and say, well, but how can you be sure about the amount of oversight with these types of events and something not getting loose in the lab? What I would say is we've been doing this for 40 years now. Over 40 years, if you start to look at things like rinderpest as well as Ebola, and we haven't seen sudden spillover events or outbreaks in locations that would suggest that there was actually intentional or unintentional release. So I think that those are things to keep in mind. Is that this type of work that's being done in these labs is not new. It's been being done for ages. And there simply is not data to or events to suggest that there have been massive intentional or unintentional releases of these viruses.
So essentially what you're saying is with COVID-19, which spreads through droplets, airborne droplets, through speaking, coughing, whatever it may be, or if those droplets are on certain surfaces, people may touch those surfaces and then it spreads like that organically, right? What you're saying is it spreading like that is drastically different to it being weaponized from a laboratory. Is that what you're basically saying?
Yeah. So I would agree with that. And I think what we're seeing right now is, listen, even when you look at COVID-19 and the spread of COVID-19, we know that ultimately, there are a lot of people that are infected and don't show symptoms of disease. So now I think what we need to start to figure out is, okay, well, what are the reasonings or the differences for why COVID-19 is different in some people than others? And we're getting some observations for why that occurs. But I have not personally seen any information whatsoever to suggest that it was ever weaponized or even that coronaviruses were viewed as a potential bioweapon agent.
Okay, COVID-19 spreads through airborne droplets, right?
Right.
So can it not be the case that, again, I'm just playing the theory
Sure.
out here, yeah? Can it not be a case then COVID-19 can be taken out of a lab and then gets inserted into something like a water irrigation system, right? Because if it spreads through airborne droplets, can it not spread through water or certain liquids?
So another great point, right? And now we get into this idea of how long is the virus actually stable for, and that now brings into effect a massive difference. So physiologically, when we look at viruses and viruses that infect us, they basically have evolved over time to be very specific to the environment within our bodies, which means that at very specific pHs and in very specific environments, they remain stable. And if you take them out of those environments, basically what happens is they fall apart. So now when we look at this idea of weaponization, unless you can basically intricately reproduce everything that occurs within the lungs, including the size of droplets that the virus attaches to, the specific makeup of those, as well as the amount of virus that is needed on each droplet to then be transferred to somebody, it simply, in my mind, is just, it's inconceivable that it could work. And I think, again, that goes back to the sense of, like, nature has been doing this for so long that nature's an expert at it. We are still in an infancy in understanding how any of this stuff actually works.
So you're basically saying that to replicate an environment in which COVID-19 spreads, like in the respiratory system, in the lungs, to replicate that in the outside of the body is something that's pretty crazy.
Yeah, listen, my gestalt is that viruses. So when we think about viruses, there's this kind of belief, I think, in a lot of people that because Ebola kills 50% of the people it infects, or rabies kills 90 or 95% of the people it infects, that means that it is unbelievably stable. That's actually a fallacy. And what we know is when we look at things like influenza, we look at things like coronaviruses or Ebola, these viruses are not amazingly stable. They're actually pretty weak. So when we actually look at their ability to survive on surfaces, what we see is there are any number of other organisms, in particular bacteria, that are far better at doing this than what viruses ever have been. It's just that when viruses get into our cells, they have very specifically evolved the mechanisms to manipulate our immune system perfectly. And this didn't happen overnight. It's happened over eons of time for these viruses to gain that activity.
In the scientific community right now across the world, there are scientists in labs and people within the medical healthcare frontline that are trying to work out some kind of vaccine for COVID-19. How close do you think the community is in getting to that?
Yeah, well, you probably saw me shift a little bit in my chair because I always get nervous about how to answer this because I don't want to be a pessimist.
Okay.
Listen, with vaccines, we're at a better position than we probably ever have been. I think the time frame is probably still going to be closer to about a year, even with some of the platforms or vaccines that are being tested in early clinical trials right now. And the reason being is that the unfortunate side is there's no blueprint for how to create a vaccine. This is something, again, that, listen, nature has done unbelievably well. Our immune systems have evolved over eons of time to develop specific antibodies and specific protection mechanisms against different invaders. So now if we try to create that vaccine, we're trying to essentially figure out what nature does in a very short period of time. And we're better than we were 2 years ago, 10 years ago, 30 years ago. But we still have a lot to learn. So I still think it's going to be closer to kind of that 12-month period.
On Twitter, I was going through your Twitter timeline. I wasn't stalking you per se, but you were retweeting some of your fellow scientists and virologists, some who were writing articles for the Forbes, and you retweeted a number of scientists who were basically highlighting the dangers of fake news and peddling the 5G COVID-19 theory. Just to bring the podcast to a close, what are those dangers? Besides a refusal to take vaccination, that's one.
Yeah.
Right.
Yeah.
The other would be, I guess, if you are from that line of thinking, you are not going to respect social distancing. You're not going to basically stay indoors when you've been told to isolate and respect curfews and lockdowns. But what other dangers do you see from those who are quite hell-bent on this theory that we are not going to take vaccines? Vaccines are actually part of the wider problem. They want to whoever they are, they want to create vaccines that's going to further destroy our bodies. We're not going to take vaccines. We're not going to respect social distancing. We're not going to respect isolation. Are these the kind of dangers that have real life implications? Is that what you and your colleagues were kind of alluding to on Twitter?
Yeah, and listen. I grew up in Canada, in central Canada, so I like to think that maybe we're a humble nation, and we kind of tend to try and look out for the betterment of the people around us. I look at this as the sense that we, especially the scientific community, we have basically a reason and really, I guess, a public need. And a social contract to provide protection for the most vulnerable around us. Because ultimately, our ability and our safety and our lives as a whole really are dictated by those that are most vulnerable. In particular, when we look at something like COVID-19, if we want to curb transmission of this virus, in basically the time frame we're in, where we have no vaccines, we have no therapeutics, we rely on the most vulnerable regions to be able to also curb transmission. So what my concern is right now is that when we look at, basically some of the posits that have been made on social media, what I don't think a lot of people realize is the ramifications of those for very vulnerable regions. Places in West Africa that I visit frequently, or across Central Africa, and that those messages resonate in those communities. We have some ability here to shelter in place until basically a time point that maybe the virus disappears, like SARS did. But in the most vulnerable regions of the world, they don't have this ability. They don't have the ability to not work or get food. And that's my number one concern, is that ultimately the messages that we're seeing will have a drastic influence on those cultures. And we owe it back to those people to provide back to the communities and provide them the protection that they may not necessarily be able to provide themselves.
Let me then posit this to you. We have celebrities in the West, right? We have them in the States. Very recently, we had a very famous former world champion boxer in the UK who are telling millions of their followers that, look, this is caused by 5G and 5G masts, right? There are 5G engineers that have been threatened and beaten up in the UK, right? What would your advice be to those who are persisting in propagating this theory amongst the community of anti-vaccine guys as well as celebrities? What would you say to them if you had their ears and attention? What would you say to them?
Yeah, so it's always tough for me to think about, okay, how do I do this without any four-letter expletives? So honestly, my easiest way of saying it, and listen, it may sound somewhat attacking, and maybe it won't. My suggestion would be spend some time in basically a low and middle income country during an outbreak. And tell me that we shouldn't be doing everything we can to help the most vulnerable around us. And tell me that viruses and infectious diseases don't have unbelievable implications socially for hundreds of years on populations. When I look back on West Africa, what we saw were entire families that were being wiped out. And I basically, went through and did that, essentially led that diagnostic testing on a daily basis. What we tended to see, though, were a lot of kids that survived. Those kids are now orphans and have been ostracized by their communities because of a disbelief in infectious disease and a belief that those kids may be poisoned or may bring the virus back. Those are the images that I carry with me every day. And I likely wouldn't have had that strong of a feeling had I not been there. Those are the concerns that I have, is that it is much easier for us, I think, to look at these types of things and say, it's an inconvenience. There is some other explanation for this. And we simply do not need or have the time to be inconvenienced to allow this to basically be contained. The rest of the world doesn't have that convenience, and they sure as hell do not have that time that we have. So if it means that we unfortunately have to basically go through short-term suffering by not being able to go out and do the things socially that we want to do, it's a small price to pay to be able to enable the lives of again, the most vulnerable around us.
I mean, you yourself are from Canada, you got the States on the south, I'm from the UK, Western Europe and North Canada, Australia. There's many countries which is regarded as the Western world, and they champion, or at least claim to champion, freedom of speech, freedom of dialogue, freedom of thought. And what's been happening of late is that there's a number of social media platforms like Facebook and YouTube that are now taking down content, right? For example, the most prominent probably is David Icke. He did an interview very recently. YouTube took it down. It received millions of views and shares before it got taken down. What would you say to those who are basically saying, look, guys, there you go. They're shutting us down because I don't want to hear the truth.
Yeah.
Putting that aside, what's your thoughts on censoring this kind of debate and discussion, which is seen as alternative?
Yeah, well, we're in unprecedented times, right? I mean, listen, this is the first pandemic where we've seen basically social media play a central role in our ability to provide information across scientists and across the globe for the public.
Do you support the censorship?
Well, that's the thing. I don't know where I sit on it, because there's the concern about the fact of, if we don't have censorship, does that enable basically the suffering of people, in particular for their physical health and well-being? So in particular with COVID-19, by spreading rumors that it's not real, how do we account for the people that then get sick and die or have long-term disabilities? But then there's the other side of saying, but we also know that we need basically freedom of speech to be able to exercise our rights as citizens, to be able to speak our mind. I don't think I have an idea on how to balance that out yet. And that's why I always go back and listen, I'm a simple virologist. There are people that I hope are far smarter than me that are looking at these from a policy standpoint. But it's something that we're not going to solve overnight. And we have to find that delicate balance of what is free speech versus what is something that is potentially harmful physically or to be fair, mentally to others. And I don't think we're at that stage of a solution yet.
Without cornering you in a position, if you were a policymaker and there was a big red button for you to press that would essentially shut down the David Ickes and the Thomas Cowans of the world, with those who are basically saying, look, guys, this COVID-19 thing is not real, it's to roll out 5G. If you were to just press that button and you had the authority to shut down these alternative views, which many amongst your peers and your background are saying, look, this is having real life implications. Would you press that? Would you press that button?
Well, I'll give you another situation, right? So when we look at anti-vaxxers, one of the things that those of us that have fought with anti-vaxxers have said over ages now has been, is it better for us to fight and provide context and provide data and reliable information, or is it better for us to just mute or block those people on social media? And I tend to look back and say, if we just block, and if we just basically try and close down all these conversations, do we actually end up enabling them and basically creating a system that actually helps fight their fight for them by saying there is something to this and nobody wants you to know it, and that's why they're shutting it down? So my concern is that if we do that, what happens is that it's only going to basically enable those people and enable those messages. But we have to find that balance with being able to provide reliable information, because in a lot of cases, these groups are unbelievably well organized. And that's the thing I think that we haven't come to appreciate yet. And we've started to come appreciate it with the anti-vax community, is that this isn't just one person in their basement or one person on their cell phone on a bus. This is basically groups of in a lot of cases educated people that are putting. It is, and like I said, they are educated and they know how to manipulate the data to present an argument. We need to figure out how to counter that and do it in a way that's constructive, but also plays to our strengths. And I think we need to do that.
But surely with any kind of data, be it scientific, be it sociological, whatever it may be, data is essentially there to be manipulated. Essentially, each camp does that, right?
Yes. Yeah, and I think that ultimately is what comes down to trying to provide context in terms of what it means, but also providing altering opinions, right? So with a lot of the COVID-19 data that's been presented, the good thing is that when somebody has basically put up a paper or put up some results on social media, even if that person is unbelievably highly esteemed, you will have people that will provide counter arguments for why they maybe think their interpretation is different. And I think that's important, again, is to keep in mind that we need to be able to show that, listen, as scientists, we are not infallible. We will sometimes get information wrong or data will change. And we need to be open with that and provide that back to the public. It's part of our public service as academic researchers and as scientific and medical researchers.
Dr. Kindrachuk, it was an absolute pleasure having you on.
I appreciate it so much. It was a fantastic conversation.
No, thank you very much. I think it's also important for our listeners and our viewers to know that Dr. Kindrachuk kindly donated an honorarium that we offered to a charitable cause of our choice, and we have decided to give it to a local NHS support charity in Bedford. Thank you for that, Dr. Kindrachuk.
Great. No, thank you very much.
Stay blessed, stay safe, and I'll hope to speak to you soon.
Absolutely.
Care.
Cheers.
Take care. Brothers and sisters and friends, you heard everything from Dr. Kindrachuk. For those of you, depending where you are in the argument, where you are in the fence, I hope you can take what the good doctor informed us of today, research the stuff he said it himself, and try keep at the back of your mind that the preservation of life is perhaps one of the greatest, if not the greatest value that mankind should actually aspire towards, right? And whilst we are so quick to share information on WhatsApp and Telegram groups and social media, please think about the ramifications that sharing content, especially unverified content, can have to people. I mean, at least from an Islamic standpoint, we know that our faith tells us to verify information before sharing. We even know from the statement of the Prophet Muhammad, he said that it is enough for one to be a liar if he merely shared everything he heard. And I would like to thank Dr. Kindrachuk for his contributions for today's podcast. The updated stats for the number of coronavirus cases in the world, as well as the death toll, as well as that by country, should be there on the screen. Guys, take care, stay safe, stay well, and until next time. And by the way, subscribe to the 5 Pillars YouTube channel, like and share this video. Take care. Assalamu alaikum wa rahmatullahi wa barakatuh.
Blood Brothers Podcast. 5 Pillars of Mad Monolith production.